Alright, Assalamualaikum warahmatullahi wabarakatuh. Kita sambung kembali ya. So sekarang puasa, so tak boleh nak minum, just tengok saja. Okay, so now we move on into the next subtopic, still under enzyme topic. Alright, so this is under KSSM. So pelajar kena tahu tentang naming of enzyme, macam mana enzyme ini dinamakan. So actually dengan menambah satu perkataan ASE dekat belakang. Contohnya adalah, penambahan ASE ini merujuk kepada substrate yang enzyme tu catalyst. Contohnya kalau lactose ni adalah substrate. So enzimnya adalah lactase. Kalau maltose, enzimnya adalah maltase. Kalau sucrose, enzimnya adalah sucrase. Tapi ada certain enzim dia tidak ada akhiran ASE, iaitu contohnya trypsin, pepsin, adenine. Kenapa dia tidak ada akhiran ASE? Sebab apa? Enzim ini being discovered sebelum this systematic naming system being introduced. So that's why namanya berbeza dengan penamaan enzim yang lain. Okay, dia ikut yang biasanya yang lain dia ada akhiran ASE mengikut substrate, tapi yang ni nama dia ada nama dia yang tersendiri. Okay, next. So these are the general characteristic or properties of the enzyme. So you all dah tahu. Okay, cuma teacher nak sentuh tentang cofactor. So cofactor ni adalah penggalak. So bila adanya cofactor, enzymatic reaction akan increase more. Okay, contohnya adalah vitamin B. So vitamin B ni adalah cofactor. Remember, teacher selalu pesan ambil vitamin B ataupun B complex, right? So B complex ni dia bila you ambil B complex, sebab apa kita ambil B complex? B complex ni dia adalah cofactor yang akan mempercepatkan enzymatic reaction. So dia bertukarkan protein yang awak makan, dia bertukarkan lemak yang awak makan into energy faster. So sebab apa? Vitamin B adalah cofactor untuk tindakan enzim. So selain pada vitamin B, kita ada magnesium, ion. Okay, so next, kalau tadi cofactor penggalak, ada juga inhibitor. Okay, inhibitor ni adalah perencat. Okay, contohnya adalah heavy metal such as lead and mercury. So that's why mercury ni bahaya. So mercury kenapa dia bahaya pada manusia? Dia adalah inhibitor kepada enzymatic reaction. So this is how mercury akan memberi kesan kepada kesihatan manusia. So dia boleh mengganggu tindakan enzim. Okay, yang lain semua awak dah belajar. So teacher boleh terus move on kepada the application of enzyme. So untuk syllabus KSSM, pelajar kena tahu satu teknologi baru kita panggil immobilized enzyme technology. So apa dia immobilized enzyme technology? Basically immobilized enzyme technology ni adalah di mana enzim ni kita lekatkan dia kepada inert materials yang mana dia boleh menyebabkan enzim tu become stable. So dia boleh maintain, dia tidak akan memberi kesan kepada perubahan temperature dan juga pH, so that this enzyme still can react at maximum rate. So don't worry, teacher akan tunjukkan video selepas ni apa dia immobilized enzyme technology. So dekat mana immobilized enzyme technology ni digunakan adalah contohnya dekat production of high fructose corn syrup, pectin hydrolysis. So apa dia pectin hydrolysis? Don't worry, teacher akan mention, and also dekat production of biodiesel. So now kita sama-sama tengok apa sebenarnya immobilized enzyme technology.
Enzyme immobilization and testing its application. This practical is all about enzymes. It's all about those biological catalysts that are protein in nature and folded into that three-dimensional globular shape. In this practical, yeast was used and yeast cells contain the enzyme sucrase. Sucrose solution was also used. The sucrose acted as the substrate, and the substrate was changed into glucose, which was our product. So what exactly does immobilization mean? The correct definition is that immobilized enzymes are enzymes that are fixed to each other or some other inert material. We immobilized our yeast cells by trapping them in a gel, and that gel was sodium alginate. The gel was prepared by mixing sodium alginate and distilled water in a beaker. The yeast was prepared by mixing it with distilled water in a separate beaker. The yeast solution was added to the sodium alginate, so it was added to the gel, and this mixture was mixed very well. Separately, a calcium chloride solution was prepared. The next step involved drawing up the yeast and sodium alginate mixture into a syringe. Very slowly, small amounts of the yeast and sodium alginate mixture were dropped from the syringe into the beaker of calcium chloride solution. As this gel and yeast mixture hit the calcium chloride solution, perfect beads were formed, and the function of the calcium chloride solution is to harden the beads. When all the yeast and sodium alginate was dropped from the syringe into the calcium chloride solution, we let the beads sit for 10 minutes to harden. The beads were removed from the calcium chloride solution and washed with distilled water. Washing with distilled water removes any possible free yeast that might be on the outside of the beads. So that was how we immobilized our yeast cells in a gel. Here's a rough diagram of one of those beads. So you have the alginate gel, you have the pores, and you have the yeast cells inside. Do we have to use a gel? No, there are other methods of immobilization. The first way of immobilizing would be physical methods, so just as we did, trapping in a gel, or another way would be to attach the enzymes to ceramic beads. Chemical methods of immobilization would be to bond the enzymes to physical supports or to bond them to each other. Now that we have immobilized our enzyme, we have to test its application. What's it like to use? The first thing we did was we transferred our beads to a separating funnel, and we had a straw in the funnel to prevent the tap from getting clogged. Then we added our substrate, which is the sucrose solution. We immediately tested with a glucose test strip, and then every 2 minutes afterwards the solution was tested. The process was continued until the glucose test strip changed colour to indicate the presence of glucose. So all good scientific experiments need something for comparison, so they need a control. Our control was free yeast in the separating funnel, and then we added our sucrose solution. We tested straight away using a glucose test strip, and then every 2 minutes until a positive result for glucose was obtained. The results. Let's discuss the immobilized yeast first. It took much longer for a positive result for glucose to appear, but the product was much clearer. Why did it take so long for a positive result? Well, the sucrose has to make its way in through the pores of the gel and then has to mix with the yeast cells, and the product has to find its way out of the pores. That takes time. In contrast, the free yeast tested positive for glucose much faster, but the product was mixed with yeast. What is the benefit, or what are the advantages of immobilization? The first is that immobilization stabilizes the enzyme. The second is that the enzymes can be reused. The third is that you get a purer product, a product that does not have to go through purification. Be sure you can give some examples of enzymes in use and consult your textbooks for relevant examples, but here are a few. Pectinase is an enzyme that's used in food processing. It's used to extract juices, particularly from apples and oranges, and it's also used to clarify, to remove the cloudiness from fruit juices. Glucose isomerase is used in industry to convert glucose to the sweeter tasting fructose. This avoids you having to add more sugar to your product. So that was the practical on enzyme immobilization. It ties in nicely with revising your enzymes, checking out bioprocessing, single-cell proteins and bioreactors. Good luck. Enzyme immobilization and testing its application.
Alright, so kita move to the next slide.
This practical is all about enzyme.
Alright, so these are the applications of the enzyme in KSSN and also IGCSE syllabus. Contohnya boleh baca dekat sini lah. Apa kegunaan enzyme? Dekat sini contohnya digestive enzyme that are being used in the medical sectors. For example, apa dia digestive enzyme? Contohnya macam lipase, amylase, trypsin, and then contoh yang kedua adalah lactose enzyme. untuk produce the lactose free milk, sebab some of us dia tak boleh, dia lactose kita panggil sebagai lactose intolerant. So bila dia minum susu je dia akan jadi sakit perut. So untuk this kind of people kita bagi susu yang dipanggil sebagai lactose free milk. So macam mana lactose tu bagaimana susu tu kita boleh buang lactose dia adalah dengan kita tambah adding semasa production dia, kita tambah lactose enzyme. And then pectinase, awak dah dengar tadi dalam video clip macam mana pectinase ni digunakan untuk produce a clearer juice. Juice dihasilkan dalam kuantiti yang banyak dan colournya lebih clear. So kita tambahkan pectinase and also cellulase enzyme. And then the next one is amylase and lipase, protease, cellulase enzyme in biodetergent. Contohnya adalah Biozip. So Biozip dekat supermarket tu, kalau awak tengok, ataupun satu lagi Attack. Kalau awak tengok ingredientnya tu dia ada tambahan enzyme dekat belakang. Dekat ingredient boleh tengok kat belakang kotak ataupun bekas yang beli tu dia ada tulis ada tambahan enzyme. So kenapa ditambah enzyme? Untuk mempercepatkan proses pembersihan baju-baju tu lah, sebab enzyme ni dia akan react dengan substrate tertentu yang mengotorkan baju you all. And then the next one is protease. So protease ni sejenis enzyme yang akan react on protein. So dia boleh separate the fish skin, untuk kita keluarkan skin fish. And then the next one is trypsin enzyme untuk penghasilan leather products. Okay. Untuk IG dia lagi detail sedikit lah. So macam mana enzyme yang teacher sebut tadi boleh bertindak. So dia boleh break down the color insoluble protein. Yang causing to become smaller color soluble polypeptide. So that's why dia boleh menghilangkan kotoran. And then can wash. This enzyme juga dia design untuk boleh bertindak juga dekat lower temperature. Tapi I think kalau kita nak supaya tindakan sabun ni boleh berkesan, sepatutnya kita rendam dia dalam ice warm. Okey, ni dalam syllabus IG macam mana enzyme digunakan dalam food industry. So pectinase ni dia akan breakdown substances in apple cell wall, which is the pectin. So boleh menyebabkan kita boleh extract keluar jus apple tu dalam kuantiti lebih banyak dan juga colour dia become more clear. And then lactase tadi, dia boleh break down lactose, so untuk produce milk, okay, lactose free for those yang lactose intolerant people. Alright, the next one untuk IGCSE, pelajar kena tahu tentang peranan enzim dalam seed germination. So ni gambar yang menunjukkan tentang proses yang berlaku semasa seed germinate. Okay, nampak ya, ada starch. Okay, starch tu mesti ditukarkan kepada maltose. So macam mana starch tu untuk ditukar pada maltose? So dalam bentuk maltose lah tumbuhan akan gunakan untuk proses germination. This embryo plant akan gunakan. So macam mana proses itu berlaku? Tengok penerangan dekat sini. Okay, so seed contain stored food dalam bentuk starch tadi. Okay, so starch ni dia adalah insoluble. Jadi starch ni kita kena tukar dia kepada soluble molecule, which is tadi maltose, untuk tindakan enzim. So that's why kita perlukan bantuan. Apa bantuan dia adalah iaitu water and also gibberellin, and gibberellic acid ni adalah hormon untuk stimulate production of amylase tadi. So dengan kehadiran amylase tadi akan breakdown starch kepada maltose. So bila dah jadi maltose, so proses penukaran ini akan menghasilkan ATP. So this ATP lah yang akan this kind of energy dan bentuk ATP ni lah yang akan digunakan oleh embryo untuk dia facilitate, untuk dia memulakan proses germination. Pada masa yang sama, glukos juga akan digunakan untuk sintesis selulose. Remember selulose? Selulose terdapat pada cell wall of the plant cell. Okay. And then the last part untuk topik enzim adalah pelajar kena tahu proses penghasilan enzim, iaitu spesifik kepada extracellular enzyme. So apa di intracellular enzyme and extracellular enzyme kita akan ajar selepas ini. So mula-mula kita akan tengok dulu macam mana proses production of extracellular enzyme. So sebelum faham proses ini, pelajar kena tahu dulu struktur-struktur yang terlibat dalam proses penghasilan extracellular enzyme. So I mula dengan ribosome. Remember ribosome? Yang kita dah belajar dahulu dalam chapter 2. So ribosome ni adalah the bone ribosome. Dia melekat pada rough ER, rough endoplasmic reticulum. And then, so pelajar kena tahu kat sini adalah rough endoplasmic reticulum, and then ada satu bulatan kat sini kita panggil sebagai transport vesicle, and then ada Golgi apparatus kat sini, and then selepas Golgi apparatus, antara structure Golgi apparatus dengan plasma membrane ada satu structure lain kita panggil sebagai bulat juga, kita panggil sebagai secretory vesicle. So these are the structures yang involved dalam production of extracellular enzyme. So I mula dengan ribosome. So apa peranan ribosome? Dia ada terlibat dalam protein synthesize protein. And then after protein is being synthesized, so dekat sini kita guna istilah protein lagi. So bila dia being synthesized, so this protein dia akan lalu lumen of the ni kita panggil lumen of rough ER. So bila dia lalu dekat rough ER ni, kemudian at the end of the rough ER dia akan keluar. Kita panggil buds off. So lepas dia buds off ni, dia ke bentuk bulatan. Kita panggil sekarang, so protein ni sekarang being enclosed dalam satu kapsul. Kita panggil sebagai transport vesicle. And then apa yang berlaku seterusnya adalah, so this transport vesicle yang mengandungi protein tu dia akan pergi menghampiri Golgi apparatus dan dia akan fuse. Okay, once dia dah fuse ke dalam Golgi apparatus, protein ni sekarang akan lalu pula dalam lumen of the Golgi apparatus. So dekat sini, remember peranan Golgi, dia akan modify. So dia akan tukar protein yang umum tadi kepada enzyme dekat dalam Golgi apparatus. Okay, and then selepas dia lalu sambil being modified dekat Golgi apparatus, so dia akan buds off juga. Buds off kali kedua dan being enclosed dalam kapsul, kita panggil sekarang sebagai secretory vesicle. So sekarang kat dalam tu kita boleh panggil dia sebagai modified protein or enzyme. Sebelum lalu Golgi apparatus, awak tak boleh panggil dia sebagai enzyme. So kena panggil dia sebagai protein biasa lagi. Okay, kemudian this secretory vesicle dia akan move toward plasma membrane dan fuse kepada dengan plasma membrane tadi dan akan being removed out as an extracellular enzyme. So senang je. So nanti saya akan tunjukkan video macam mana proses production of extracellular enzyme.